Okay, grab a color here. If I have a honest die and I roll it, I have a 1 in 6 chance of rolling a 1, and a 1 in 6 chance of rolling a 2, and so on. If I have 2 die and I'm rolling them, I will have a 1 in 6 chance that one of them will be a 1, and a 1 in 6 chance another one will be a 1, or a 1 in 36 chance that I will get a 2, or snake eyes. For a 3, I can roll a 1 and a 2 and a 1, okay? So I have a 1 in 6 chance of rolling a 1, and with the other die, a 1 in 6 chance of rolling a 2, plus a 1 in 6 chance of rolling a 2 with the first die, and a 1 in 6 chance of rolling a 1 with the second die, and therefore I have a 2 over 36 chance of rolling, or 1/18th of rolling a 3, or some combination of dies. That, if I continue this out, with all the numbers, for 2 die, I'll have a 1/36 chance here, 2/36 here, 3/36 here, 4/36, 5/36, 6 out of 36, and then it goes back the other way. 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and 1 out of 36, which would be a double 6. If I add all these numbers up, 1 plus 2 is 3, plus 3 is 6, 10, 15, and there'll be 15 on the other side. It's 30, 36 out of 36. I have a 100% chance. Okay, here's my die roll program that I've written in Matlab. I asked how many rolls do you want to make? N is the number of rolls. It forms a random number for one die and for a different die, 2 different random numbers. Okay, those 2 are added together to give you a number between 2 and 12. Okay, and they are added up to see how many 2s I got, how many 3s, how many 4s for a particular die roll based on a random sampling. In addition, I came up with what the probability was, which is that 1/12, 1/6 for each die roll, and calculated out for a 2, there's a 1 in 36. For a 3, there's a 2 in 36, and so on. Okay, calculated those out and plotted those on the same plot. So let's go ahead and run this. It asked me the number, let me just show you. It asked me the number of rolls. Let's just do 10 rolls. Okay, and when I run 10 rolls, you can see 20% of the time I got a 6, 20% of the time I got an 11, which is unusual. Okay, but in general, it doesn't match what you would expect with a lot of rolls. So let's try more rolls. Let's try 100. Okay, so we're going to put 100 in here and see how close that comes to the. Now it's starting to look more like a normal distribution. So we're feeling pretty confident about this. Let's run it one more time and do 100,000 rolls. That's 10,000, 100,000, okay? And when we do that, we see that indeed the probability is that it's going to get that normal population. Let's do 10,000, just out of curiosity. It's 10,000. Okay, so 10,000 die rolls, still very close to the normal distribution you would expect.